Hello. Today I'm going to teach you about voltaic cells. So let's take a look at our learning target over here. So today I will learn the parts of a voltaic cell, which is also called a galvanic cell, and you're going to be able to explain the reaction occurring within it. Okay. So as we go through, we're going to talk about these six important aspects of the voltaic cell that you need to know, you need to be able to describe, and you need to be able to diagram out, just like I'm going to. Okay. So we're talking about the salt bridge, reactivity, the half reactions, the balance of ions, the flow of electrons, and we'll identify the charges of the electrodes. Okay. All right, so I'm going to just push this to the side for right now as we kind of diagram out what we're going to do. Okay. All right. So first, we're going to start with a container. So this container can be a beaker, it can be any kind of glassware, really. And then we're going to put it side by side with another container. Okay. We need to fill our container with a solution. And in this one, this solution is going to be our zinc nitrate. Okay, remember your zinc is 2 plus, your nitrate is 1 minus. Now, when you dissolve an ionic compound in a solution, you're going to produce ions. So floating around, we're going to have some zinc 2 pluses, we're going to have some nitrate anions, and they're going to be floating around all over the place. All right, in this beaker over here, we're going to put a different solution. This time we're going to put copper 2 nitrates. And just like the other beaker, because it's an ionic solution, you're going to have a bunch of ions floating around. All right, so we have all of our ions kind of floating around in solution. All right, one of the first aspects that we need to add in are our metal electrodes. So literally, it's just a chunk of metal that you're going to throw in here. It could be a metal bar, it could be a metal plate, whatever. And this one, since it's in the zinc nitrate solution, we are going to make it a piece of zinc. Well, over here, it's going to be very similar. And it's going to be a bar of copper since it's in the copper nitrate solution. Okay, so it's going to look the red, brownish, just like a penny. Over here, zinc is a shiny metal silvery color. All right, so we have our bar sitting in solution. It can be sitting at the bottom, but for diagramming purposes, I just kind of had it floating there. You can have something holding it so it's submerged, but not all the way in. Doesn't really matter. All right, the next part you need is an external wire. External meaning it's outside of the reaction occurring. And it's going to be hooked up to a device called a voltmeter. Okay. So this piece of metal will be clipped on using an alligator clip. Same thing with on this side, and it's hooked up to what's called a voltmeter. A voltmeter is just like an electrician's tool. You hook it up to like an outlet or some kind of power source to see what kind of voltage it's putting out. So this, when it's all completed, depending on the reaction, it could put anywhere out from 0.2 volts, like a really weak voltage. It can go up to maybe 3 volts. It just really depends on what your metals are, your concentrations, and other things. Okay. All right. So we have these two pieces of metal hooked up to your voltmeter. All right. Now we need a really important piece of equipment. It's going to go from the fluid of one solution to the fluid of another. And it does need to be in the actual fluid part. Okay. This is our salt bridge. And I'm going to bring this part over so you can kind of see the important aspects we're talking about. So that's number one we're talking about, the salt bridge. And I know it looks really terrible, but so we're going to put NaCl in our salt bridge. For me, when I do these in the lab, a salt bridge is a thin glass tube, and I use a Bunsen burner. I heat it up really hot, and I heat it up really hot, and then I bend it into like a U shape. What's in the actual tube is some agar solution with, in this one, it's going to be our NaCl. So as I put a little bit of water in, I put my agar powder in, and then I dissolve some NaCl, mix it around, and as I heat it up, it starts to thicken into a gel. Okay, so agar can be used in food products. It just, like I said, thickens up food. We use it in biology classes to make our biology bacterial plates so that you can grow bacteria on them. So there's a lot of different uses for agar. Okay. So like I said, in this one, you have some agar, you dissolve some salt into it, and it's just kind of inside the tube and it's thickened, so it's a gel in there. Okay. And that's going to help us balance our ions when we start talking about the reactivity. All right. The next important aspect that we need to talk about is your data booklet. So if you go to your data booklet and you go to section 25, which is called the activity series, you should have already learned about this in the course, you will see that zinc is down here, but then copper is way down here. Okay. Anytime you have a metal that's higher, that metal is going to become an ion. So we look at which one's higher. Is copper higher or zinc higher? Zinc is higher. So that tells me my zinc is going to go from a metal to an ion. So it's going to go from this solid to these ions in solution. So we know right away over here, because it's higher on the reactivity scale, zinc is going to go from a zinc metal, so solid, to an ion of zinc, which always has a 2+ charge. When it becomes an ion, you have to balance its charge by adding some electrons. Okay. So over here it was just normal zinc. Over here it has an ion and it's losing electrons. So let's think back to our saying. How do we remember oxidation reduction? Oil rig, right? So here your zinc is losing electrons. Since it's on the right side of the reaction, it's a loss. So we know this is an oxidation. So I'm just going to put OX, oxidation reaction. Okay. On the opposite side, for our half reaction, we are basically going to do the opposite. We're going to start with our ion. So here we have copper, which is going to be a 2+ because it's copper 2. It's going to balance its charge with 2 electrons, and it's going to form solid copper. Okay. Here, because it's beginning and it's gaining electrons in the beginning, okay, we call this a reduction reaction. Okay. So there we have our half reaction. So we went through 1, we talked about our salt bridge. 2, our reactivity. 3, our reaction, our half reactions. And in a second, we're going to talk about flow of electrons and balance of charges. Okay. So now that we have our half reactions, we know where the electrons are being produced and we know where they're going to. We're going to diagram out the flow of electrons. So since they're being produced at our zinc, we're going to show arrows that they're flowing from the zinc all the way over to our copper. And I'm going to mark these with E negatives because those are electrons that are flowing. It's how we get an electrical current. Start at your zinc, move all the way over to your copper. And that's how we produce them here. With our zinc, we produce the electrons, and over here, they're being used to make copper. Okay, so that's our flow of electrons. That's number 5 on that list. All right. A couple things that you need to know that are happening before we do the balance of ions. Okay, go back to this. In this reaction, the solid zinc is becoming ions. So literally, what is happening to this bar is it's eventually going to be eaten away. It's going to lose mass because some of the zinc is going to come into solution and produce more zinc plus. Okay? And the opposite is going to happen over here. Since our ions that are already in solution, they're going to gain electrons, which are all on the surface of this, okay? And they're going to form more copper on the bar that's already in there. So you're going to add mass over here, okay? Now, this causes a problem. You're actually producing more ions over here, and you're giving away some ions, so you're having less ions on this side. So the purposes of this salt bridge is to balance that interaction, okay? Since over here, we're producing more zinc plus. We need a partner to balance it out. So in our ionic compound, our chlorine, which forms Cl minus, is actually going to come over and balance your extra zinc ions that are being produced. Okay. Over here, your copper is disappearing. So we have all these leftover nitrates that need a partner. Well, sodium forms an Na plus, and that can be a nice partner for all these nitrate ions. So now you have your balancing of charges. Okay, that's the purposes of the salt bridge. It allows a flow of your ions. Okay, doesn't allow a flow of electrons. It allows a flow of ions between your two half cells. Okay, now that we've talked about pretty much all these parts, I want to go to number 6. We're going to identify the electrodes. So in a voltaic cell, you need to know what the cathode is and what the anode is. Okay, a nice way to remember that is anox and red cat. Okay, we have reduction over here. So this electrode is going to be labeled as our cathode. Our cathode has a positive charge. So this electrode right here is going to be positive. Okay. Over here, this electrode is going through oxidation. So that's going to be our anode. And it's going to be a negative charge. Okay, it's producing electrons that flow over to the positive. So now we have all the important aspects labeled out. We know our half reactions, which can collapse if you wanted it to into zinc plus copper 2. We cancel out the 2 electrons since they're on both sides. Cancel, cancel. That produces copper and zinc ion. Okay. All right. And there's your reaction. If you have any questions, make sure you ask us in class and we can describe this into more detail.